Hello YouTube. 22 years ago in 1999, ILM developed the EXR file format. Well, today I'm going to be showing you some new ILM technology called Lama, which stands for Layered Materials. So to understand Lama, we need to understand what each node does. Now there are 7 main nodes which I find myself using quite commonly, which are the diffuse, translucent, SSS, dielectric, conductor, sheen, and emission. Diffuse is used for base color, so this will influence the major color of the shader. We then have translucent, which we'll use for paper and leaves. It basically fakes a subsurface scattering effect. We have SSS, which we can use for actual subsurface scattering, which can be used for your base color. And it's usually used for organic materials such as skin and wax. We then have dielectrics, which are used for specular. So it basically replicates refraction and coatings. We then have conductors, which are specular for metal. So we have some pretty complex IOR settings in there, as well as a more artistic setting. We then have sheen, which we can use for peach fuzz, dust, and clothing. And finally, we have emission, which we can use for light, screens, and LEDs. So how can we combine these layers together? Well, Lama has an order of operation, which I'm going to go through now. So as we can see along the bottom, we have a mix along the bottom, which means that all of the ones going from left to right is the order in which we mix them. So for example, say we have a diffuse and a translucent, we can mix those together, or a diffuse and a subsurface, we can mix those together, and so on. On the left-hand side, you can see we have layer, which basically just means stack. So for example, we can stack a dielectric on top of a diffuse, and that way we can have a specular on top of our diffuse shading base color. We can gradually get more complex with this process and start layering multiple nodes on top of each other. So for example, with a skin shader, we'll start off with the subsurface, and then we'll have 2 layers of dielectric, and then a peach fuzz. So let's take a look at some working examples. Okay, so let's take a look at some of these materials in this scene. So at the moment, we currently have a few shaders which I think would be a good example or to show the Lama workflow. So for example, here we have a Macbeth chart, a chrome ball, and a grey ball. And then after that, we'll go on to some more complex materials. So if I just quickly close that down. Here we have a grey 18 mid-grey material, which we use on our grey ball. And you can see how simple this network material is. So we currently have a grey 18 layer, which basically means we stack these 2 layers. So our base layer here, we have a diffuse shader, and we can see that we have got this set to 0.18, which is mid-grey. And then if we come into our dielectric material here, we can see we just have the default settings with a roughness of 0.6. Now, we currently have the base material set to the diffuse, and the top layer, which is dielectric. So basically, we're putting the specular on top of the diffuse. Now, here we have a bit of a different shader. We have a conductor material, which basically is what we use for metals. So as you can see here, we're using the artistic method, where you can pick 2 colors, a face color and then basically an edge color, and it can then create a metallic looking shader. Now you can also use the scientific method, which I tend to use more commonly. And this is really great because it means you can go onto refractiveindex.info and you can get the different wavelengths, so for red, green, and blue, and then find out the index of refraction and the extinction for both of them, and it will basically be as accurate as the real world material. So next we've got the Macbeth chart. Now for this, I don't want any specular response on this, so I've literally just got a diffuse in here. So we've just got the Lama diffuse, and we've got basically plugged in a texture into the color. So it's basically powered by that, and we haven't really changed anything, and we've just assigned that. And then so on with the human scale. That's literally just a dark material, which is just a diffuse with no specular response. And then the backdrop, we've got a similar thing to the Macbeth chart, no specular response. We've just got a diffuse with our little backdrop texture. And that's it for that. So we've also got the stand, which is very similar to the grey 18. So we've just got a dark diffuse followed by a layer of specular with a dielectric. So let's actually try and build up one of these shaders. So I think probably the best one to sort of take a look at would probably be the Grey 18. So if I just quickly delete these two, we can go through the process of actually making this shader. So we can see we've got our stack, basically. It's a stack. So we stack the diffuse, we stack the specular on top of the diffuse. We can basically just bring in those two elements. So we need a Lama dielectric, which will be our specular. And then we also need the Lama diffuse. So if we just bring in that Lama diffuse, in the diffuse, we want this to be Grey 18, like we said. So we've just got to come into here, make sure color management's turned off, which means it will be the linear value. And we've already got that set to 0.18, so that's great. And then we can just plug this in. So if we just plug this in, I guess, to the base, which is where it's going to be anyway, and we kicked off a render, we would see we'd only get the diffuse contribution. I just got to quickly come into image. So when you open up this the Renderman viewport, you need to come into here if you're using Aces and just select the image color space and set it to Aces CG. As you can see here, yeah, we've literally just got a standard ball. I've got the denoiser on at the moment, but that's why it's looking a bit soft in certain areas. It's just got to go through a few more iterations. But yeah, so as you can see, we've got no specular highlight on here at all. It's literally just the diffuse component. So let's now come in here. We'll quickly stop the IPR, so we can just tweak a few things, minimize that. We will now plug in our dielectric material, which is our specular response. So we just want the out color, which we can find at the bottom of the shader. So if I just move this there and like that, I tend to put it so the layer that you're stacking on top will be above the diffuse, so, or the base even. So we're going to put this dielectric, which is basically just standard specular, in there, and we can see it automatically will fill it in to the top. So we can quickly name these, say for example, Lama, or we can name this Grey 18 underscore Lama diffuse, just so we know that that's the diffuse aspect. And oh, seeing we picked up the 18. There we go. And then we can do Grey 18 underscore Lama dielectric. There we go. And that's just to make sure we can see where each sort of we can keep track of everything, so it's a bit more organized. And now we've actually updated that, we can now take a look in our IPR. So if we just quickly open this up and we just kick it off again. Now we can see we've got that specular response, which is exactly what we want, but it's a little too tight. We can see the light very clearly. It looks, I guess, more like this sort of chrome response. So it's basically it's too shiny at the moment. It's not rough enough. So we need to come into our Lama dielectric, and we can just bring this roughness all the way up to about 1.6, I'd say, and then see in a second. There we go. That looks a bit more like a grey ball you'd see on set on a reference chart. And just to check that everything looks okay, we can turn off the denoise, and we can see, yep, that looks right. So everything's working correctly. So let's quickly just stop this IPR render right here. And we're now going to look at a metallic surface. So we'll look at this conductor. So if you just bring in a conductor, we can see here that you have, by default, it will just come in with a standard gold one. For the chrome ball, I've just put in the settings of chromium. So the face color and the edge color. You can also do this with IOR, but this is a more artistic friendly way. So I'm going to show you the amount of control we have using this artistic mode. So if we just quickly open up the viewer again, and say we set this to something pretty outrageous. We'll set the edge color to something like green. We should see now we've got that nice edge color, which is very green. And then we could set this to something outrageous as well, like pink. And there we go. Now you can see it. That's working correctly, and everything looks as you'd expect, really. So you can really get quite creative with this instead of being limited to just the IOR and tint. So it's really, really handy and pretty nice if you're doing some more stylized stuff, or even if you just want to quickly get something looking right. So that's basically how the conductor works. So let's move on to a bit more of a complex material. Actually, I'll quickly just go through showing you some other materials we've got right here. So we're going to do this on the teapot. So here we have our teapot asset. And here we've got a metallic shader. So I'm just going to quickly assign this and then kick off this render. And as you can see, we've got a really, really nice gold here. And so the way I actually made this gold material was I used the scientific data. So if I quickly open up a web browser, and I'm going to quickly stop the render. We can then go onto refractiveindex.info, and on this site we can see that we have the refractive index and the extinction coefficient. Now these are the two things we enter into the shader. So if we click here, you can see the extinction and IOR. So if we bring that back up again, we have a wavelength here, which is basically the unit of light. So it's 0.65 for red, 0.55 for green, and 0.5 for blue. So we can just come in here, copy these numbers down, and then change this to say 0.55. And that'll be the green, and then 0.45. And these values will be the blue. So that's how this works, and it's a really simple and easy way to get really realistic looking metals. So let's move on to the plastic. So I've just got a very, very simple plastic shader set up. Now it's not the most simple you could go, because the most simple would be use a diffuse response, but say we have like some small plastic pieces like Lego. This is the sort of shader you're going to be wanting to build. So we've actually used the path traced subsurface material here. So let's just quickly kick off the IPR and see how it looks. Now this will take quite a while to probably go through the works, because it is a pretty intense shader because it has got subsurface scattering, so it's not as quick as say your diffuse or dielectric materials. So if we just take off the noising, you can see here it is very noisy, but if we turn it back on, we can see how it's reacting. So we can see the edges, they're brightening up a little bit more. And they look a bit more waxy, which is exactly how you'd have in a Lego brick. So let's see how we've made this material. So I made this material pretty easily. I've literally just got the subsurface here as our base material. And so I've got, because it's such a large object and I wanted to replicate quite a small object like a Lego brick, I've basically scaled it up 10 times. So realistically, if you're working in a scene, you'd have the asset 10 times smaller. But in order to just visualize it in this scene, I've scaled it up 10 times in the SSS. And then here we've just got a IOR of a common plastic of 1.481. It's usually around the 1.4 to 1.5 mark. And yeah, that's pretty much it. We've put the radius to the color we want, and that's just all the settings. So we've got the default color of 1.8 or yeah 0.18 here for our base, and then a color of pretty much white just to get that scatter, so it scatters white in those corners. And then on top of that, we've literally then just got a standard specular dielectric. So nothing special about this. These are just pretty much the default settings. And yeah, that's it for this material. Now, the other one I want to quickly show off is the emission. So if we just quickly select our teapot and assign the emission, we can see how this works. Now, this is no different from your standard emission shader. So you set a color, and it emits some light. So let's just turn that off. You can see probably a bit better how it's working. So if we just see here, we've just got the blue color, and it's emitting that color. So this is really useful for stuff like LED screens and any sort of like light which isn't going to emit a huge amount of color. A huge amount of light. So it's not there to replace like a mesh light. is, or even just a standard light, it's pretty much there just to use on a quick little like LEDs and screens and quite small objects which don't give off a huge amount of light. So yeah, that looks pretty nice. Obviously, it's got no shadows because it's emissive. It's giving off more light than it's taking in, so you don't have any sort of shadowing. And let's go on and create a bit more of a complex material. So I'm gonna quickly just build a quick little material here. So we're gonna call this skin. Now I've got a diagram on screen here which we can see the different layers of skin. So we're going to build this using the subsurface nodes. So you could use the tricolor, but we're going to go with just the standard SSS shader. So that just means we've got a bit more control. So I'm going to put in some values in here. So if we go over to the RGB, I'm going to set these settings to probably about 0.6, 0.45, and maybe 0.3. Maybe we'll set that to 1, and then 0.6, and then maybe play with that blue a little bit. We'll just sort of try and get a bit of a skin looking sort of color. And then now we've done that, actually maybe need a bit more saturation in there. Let's turn on our color management just so we can see how it looks. Something like that. That's great. And then we've got our scale here. We'll leave that at 1 because it is a pretty good scale for the sort of thing we're going to be doing. And skin's usually around 1.4 to 1.5, so I'm going to just do 1.45 roughly. And then the radius, we want this to be the way that our skin basically scatters light is in this ratio. So 1 in the red, so that means it basically scatters a lot of red. 0.35 in the green, and then 0.2 in the blue. And that needs to be, sorry, with the color management turned off. So 1, 0.45, well actually 0.35, sorry, and 0.2. And that is how basically our skin scatters light. So it scatters more red, a bit more green than blue, but not a lot of blue. And so we could just chuck this on now and see how it looks on our teapot. So let's just quickly chuck that on and we can take a look. So there we go. We've got something that looks sort of like skin. It's probably a bit too saturated, although did we set this to the correct color space? Yep, we did. So yeah, it's looking probably a bit too saturated. If we just quickly, we'll kill this render and minimize this. We can then desaturate this. So if we come into the HSV, just pull down the saturation a little bit. Maybe more like that. Probably more like a realistic skin tone. But we need some sort of specular response. So the way we build up skin is you have basically 3 layers of skin, followed by 2 layers of dielectric, and then a sheen, which basically replicates peach fuzz. So this is basically all the layers of skin where we're actually scattering. And then we just need to now bring in a dielectric. So this will be the specular response for the skin itself, not any sort of coating or anything like that. So if we just sort of call this underscore skin, and then we'll create another one exactly identical. Seems to be still rendering, so I'm just going to quickly discard that. And then we'll call this one Lama dielectric underscore sebum, which basically is the layer of oils and sweat which we have on our skin, pretty much. So we want this to be the base, and then we want this to be. We need to layer this up now, so we stack it with a layer shader. So we get a Lama layer, and then we basically need to pull the out color into this, into the surface shader, and then we'll pull the out color of this into the base color. So if we go base, and then we need the out color of this to go into the top layer. And then we basically just need to repeat this process. So we get another layer. And we'll get the out color, and we'll plug this into the base. And then we'll get this one, and we'll plug this into the top layer. And then we just got to do it one more time for our sheen. So we'll get another layer. And we'll put this as the base. And then we'll get a sheen. So once we've got the sheen, we can then just call this Lama sheen underscore peach fuzz. And grab this and put this in the top. So we'll set this to probably a bit of a grey colour. We'll set the roughness to 0. And then we'll just come in here. So we want our first layer of skin, which will be the quite rough one, as this is our skin is naturally quite rough and bumpy. So we'll set that to probably about 0.7. And then we will set the more reflective layer, the more oily and shiny layer, probably something around 0.3, 0.4 sort of area. So I'm going to set it to 0.3. And then we just need to then grab this, chuck that on, make sure it is definitely assigned. It should be. Yep, it looks like it. Oh no, it looks like the assignment's being taken away, so we'll just assign that onto teapot. Just double check that's assigned. There you go. So now if we kick off the render, we should get a pretty realistic looking skin shader. Now obviously we're not doing this on a human, it's on a teapot. But as you can see, it is starting to look quite a lot like a skin shader. So this will take a few minutes to sort of converge and get looking nice. So I'm going to quickly pause the video and I'll be back in a second. So now we can see it's resolved a little bit more. And as you can see, it's a pretty realistic looking skin shader. Now obviously this isn't a great object to do it on, as we don't really have like areas like thickness in the air and all that. But as you can see, we've got these areas which are lighting up around the edge, and everything seems to be scattering perfectly. So if you did apply this to a model with the right sort of displacement and bump on it, then you would get a really, really nice response, and it would look quite realistic as like human skin pretty much. So I'm going to actually show you how this can be quite useful in a pipeline. So we're going to go over to Katana now, and I'm going to show you how you can build basically a set of preset materials such as the skin shader, and then save them out and use them in a production pipeline. So I've basically recreated that skin shader I made in Maya inside of Katana here. So as you can see here, we start off with our SSS skin. So this is driven by a texture, which you can literally just input the file in here. And then we then have control over all of the parameters that we want. So for example, we'll set this to 1.5 or whatever. And then we've then got this mixed with a diffuse, so we can give some diffuse contribution, which is controlled by a texture. So you know, we can then mix that in a certain amount, and then if we come down, we then stack on top our dielectric for the skin, which you know, is our high roughness one. We then have a bit of a lower roughness, which we stacked on top of that, and then once again we've stacked on top our peach fuzz, which we use the sheen node for. So what we can actually do is, with the network materials, this is just a normal network material name, which I've just named RF Lama skin. What we can actually do is we can come in here and say expose some of these parameters. So for example, we can edit the parameter name on the material interface. So we'll set this to say SSS. Actually, we'll do SSS texture, and then we'll set this under SSS. Then we'll come into here. We can see SSS texture. If we come down to our network material, we have this little drop down which just has SSS texture, and we can see that we'll have that on our interface. So if we just come into here, we can then expose some other parameters. So for example, we may want to expose the radius, which we'll set actually to 1, 0.35, 0.2. And then we'll just expose this for the artist to use. So for example, the name will just simply be SSS radius. And then we'll set this to, I think we called it just SSS. So that will be under the same menu. And I don't think we want any of these other settings. We've got the color already obviously in there, the radius, and I think we'll probably put the scale as well. So we'll just put this as SSS scale, and then the group will be SSS. So now we can see if we come down here, we've got an SSS basically tab inside of our shader, and then we'll have all of these controls. So the first thing we're probably going to want is the texture, followed by the radius, and then the scale. So we can just middle drag that up, and we'll just go through and basically continue doing this. And now we should have a little shader here where we can now control obviously the SSS, diffuse, specular, and peach fuzz. So you may be wondering how this actually looks. Well, what we can do is we can use a material, I think it's a look material, look file material out. And if we just basically plug the out into here, we can then write a look file. So I'm going to save this to a location. My desktop, I'll just call this RF, I'll call this material lib or something. And then we can just write that look file. So material lib, export. Now we can bring in a material node here, and we can then actually do create from a look file. And if we then select our look file here, and we drop down, we can now see that we have our material there. And we have all of the control of the shaders which we exposed. So this makes a really nice way that an artist can quickly come in here and say, oh, maybe the specular is a bit too much, so let's drop that by half. Or then maybe the we want a bit more of the roughness on the sebum layer, so the oily layer. So we can then set that to 0.7. And then also change the color of the peach fuzz and so on. And this just means that you're not actually affecting this material here, it's referencing it and basically creating a new material from it. So we can then hand this out to all of the artists in the pipeline, and they will have the same skin shader, which then they can just tweak these parameters to fit. Thank you so much for watching this video. I really hope you found this helpful, and if you did like it and want to support the content, please drop a like on this video, subscribe to my channel. These videos do take a long time to make, so any support is really appreciated. And yeah, if you subscribe, you'll keep updated with all of my latest posts. So hopefully you can find something useful here. And thanks for watching.